Hello. I'll give you a little bit of information which may come in helpful to other people working with building a project or debugging or whatever. An example of an atypical hardware defect, one that has a tendency to cause countless hours of hair pulling aggravation, and if it makes it into an end user product where it will cause random, I mean totally random failures of the device or the product that it's in. And I'll give you an example of how I found this one and what the exact atypical failure is. Remember in the last video, I had this unit running the test program, and as I was talking, you'd see this lead stop blinking, and I just unplug it, turn it over, show you, and plug it back in to start it from scratch. I just assumed that that lead stopping, it's blinking, or in other words, this output port no longer being updated properly was just a result of the test program running to an end and then running on down through the blank memory and rolling over and starting back and somehow messing with register 0, which is where the address for this port was stored, because it was generally happening right at the end, or literally right close to the completion of the test count for all the ports. So that's what I just assumed it generally was, and didn't really pay much more attention to it. But something in the back of my mind said something is not right here. So I went looking a little bit deeper into the situation, and looking over the code I had in the EEPROM and the rest of the contents, there should have been nothing in the EEPROM that would cause corruption of register 0. And when it did finish the program and run on through the empty space of the EEPROM and start back from scratch, the initial initialization part of the program should have reloaded the register values for register 0 and register 1. So there's no reason it should have been corrupted where it couldn't show the output. So I then started doing a little bit more experimenting. I took and burnt another EEPROM with a return at the end of the program to directly restart it back from scratch as soon as the test program or test count ran to completion, so it didn't go all the way through the empty EEPROM. And tried that, and the exact same result upon close to the end. Then this lead stopped counting, doing some probing on the data bus. All the data bus signals looked perfectly fine. I double checked to make sure there's no hairline shorts on any of the solder joints or anything like that. Then it finally dawned on me as I was watching the count and stuff. It was still putting the external memory move on the external data bus. You could still see the external memory move where it should be just a totally corrupted address that it was trying to move the data to, which of course means that it wouldn't make it onto the address 9 data latch it was intended for, but more importantly, it was happening before the completion of the count. And when I put in the original ROM that had the test program on it, it would corrupt register 0, which is the register that the address for this data bus data latch was on. It would corrupt it just before the end of the completion of the count, and once the count completed and ran through the memory and started back through again, then the data latch would start working again. The address and the register 0 would be straightened out by the initialization routine and everything, and it'd start working again and right until the end of the countdown program, and then register 0 would be corrupted again. So, done a little more digging into it and tried changing out with another microcontroller, and all of a sudden all the problems went away. With any of the dumb EPROMs, the program ran fine, either running, looping through all the way to the end, starting a direct reloop. It worked fine. So I went diagnosing into this microcontroller a little bit more, put it back in, done some little more probing, and surprisingly enough, what I concluded was that there is a proximity effect going on between registers 2, 3, and 4 and register 0. 2, 3, and 4 was the ones that I would have the test count running and then being forwarded to the individual ports in question. And register 0 is the one I had the static address for this output port on, and register 1 is when I'd have the static address for this memory mapped output port. Register 0 is the only one being affected, register 1 wasn't, and it would only be affected when there was a specific count on registers 2, 3, and 4. I could tell pretty much that the most significant bit in register 4 had to be 0 plus a certain specific set of values in the other bits of the other two registers. Then it would cause corruption of register 0, and it wasn't a FFF value or a straight 000 value, because either of those values cause no corruption in register 0, but strictly a 1000 or so on register 4 plus another specific count on 2 and 3. Then register 0 would be corrupted and it no longer properly forward data to the output port, memory mapped output port in question. And if you're dealing with software debugging or prototyping and stuff, you won't be able to tell that there's any defect in the hardware except under very specific instances where something just stops working properly, and you won't be able to reproduce the problem because the likelihood of having that exact values loaded into the other registers while having a key value in register 0 is like being hit by lightning, and it's way beyond the test standards that Intel or any other manufacturer would put it through. And it also causes, if it's in an end user application, just totally random crashes or equipment failures that'd be totally unreproducible. And it's one of those atypical equipment defects that has a tendency to cause countless hours of frustration. The only reason I caught it with this is because the early simple stages of the design that I'm at and the thoroughness of heavily exercising the registers in question, which finally provoked the defect at this and only this one chip has. Luckily enough, I was thorough enough to poke into the situation a little more and figure out what's going on. Otherwise, this chip could have caused me hours and hours of hair pulling and frustration. So when you have an application or a product or a design that you're working on that just is randomly doing something totally off the wall, it may not be your code. It might not be a hardware design. It may be an atypical hardware defect in one of your chips. And when you're presented with a situation like that, it's often a good idea to change out the primary chips in question to see if the problem goes away. Because like this one here, you may get hit by lightning and get one of those chips that is just destined to cause you problems if you don't figure it out and catch it as soon as possible. So take care, take it easy.